So question 2 on the Core 2 Transformations review sheet. Again, we're describing transformations, and you'll notice in this case they all involve, these transformations, adding or subtracting numbers into our equations. Now this means they're all translations. So in this case, talk about translations, you can link this to your knowledge from Core 1 when you did quadratics and drawing quadratic graphs. These are all in completed square form. So describing the transformation, in the first one, so A part 1, we've gone from y equals x squared to y equals x squared plus 28. So we've added 28 onto the right hand side of the equation there. Now this is a translation upwards, so it's a translation by the vector 0 in the x direction and 28 up in the y direction. Now this is because using our table, if you rewrote that equation, this is the same as y minus 28 equals x squared. So that fits in with our table. Y has been replaced by y minus 28, so the vector is 0, 28. So looking at part 2. So what's happened in part 2? Well, this time the number's been added to the x. It's inside the bracket because this is a translation in the x direction, which means left and right. So this time it's translation by a vector negative 12, 0. So x has been replaced by x plus 12, which means when we write our vector, that's actually 12 to the left, and that's written as negative 12. And so the last one. Well, in the last one, the x has been replaced by x take away 45, and there's been 25, sorry, it's subtracted from the end of the equation. Now this is like replacing x with x minus 45, which makes the vector plus 45 in the x direction, and y has been replaced with y plus 25 because it's minus 25 on the end of the equation, which is going to make the vector in the y direction negative 25. So this is a translation by vector. So in the x direction we need to change the sign. It was negative 45, so it's actually positive 45. And then in the y direction it's the number that's been on the end because y has been replaced with y plus 25. So that's negative 25. Now you mustn't forget there's a second part to this question, which is then to sketch the graph and state the coordinates of the vertex. So let's start off by having a look at an x squared graph. So we can start off by drawing a basic x squared graph. So remember what the shape of that is, and that's going to go through the point 0, 0. So the vertex is at 0, 0. So the first one was x squared plus 28. Now we said this was a translation by vector 0, 28, which means our x squared graph has got to go up 28 squares. So we've moved our graph up 28. Now this makes the vertex now is 0 in the x, but 28 for the y coordinate. So part 2. Now we're doing y is x plus 12 all squared. Now we said that x plus 12 all squared was a translation by vector negative 12, 0. So that means we're going to take the vertex was at 0. It goes negative 12 in the x direction, so 12 left. And then we just sketch our graph. So in this case, the vertex is at negative 12, 0. And then our last one. Our last one is y equals x take away 45 all squared, take away 25. So that's a translation of 45 to the right and 25 down. So that moves my vertex to 45, negative 25, and I can sketch my graph in. So remember, this relates to completed square form from core 1, where the coordinates of the vertex we can read from completed square is 45, we change the sign on the x, and negative 25 stays the same for y.